Yo, how we doing? How we sounding? Looks like we're up and running. Mic's working. YouTube and Twitch are going. Alright. Let's get straight into it. All quiet, early afternoon. Just a few of you here. Thanks for joining. I'm going to go straight into overhead and we're going to start seeing about this build. Right. Hey Derek. Thanks for joining, buddy. Thanks for giving me the sound check too. Okay, I'm going overhead. Let's go overhead. Boom. Scooting over. Hello, here we are. Okay, what's going on? I want to build another one of these today because I'm going tomorrow down to the show, and so far I only have this one built. This is going to be interesting because my solder paste hasn't arrived, so I'm gonna try and hand solder this, which is always fun. Luckily, I've got some new microcontrollers already. So let's get into one of these and see if we bought the right one for a start. Seems like a good time to try the microscope out. What's up, Derek? What are you up to today? Try and be delicate with this. Oh, look, there's a solder blob. A solder blob on my microscope bottom. Mega 32U4. That sounds good, doesn't it? Let's just compare it with what we've got on here. Mega 32U4. Quite hard to read that, isn't it? Alright. I think we got the right thing. And hopefully it fits. On here. Checkmate display. What's a checkmate display? Get this alignment right. So we're going on here like this, I think, because in one is designated on the silk screen. And let's do a picture in picture. And I'm getting this right. Wait. Yeah, is that all right? Pretty good. So the dot is in the bottom left, and on this one, dot is in the bottom left. Awesome. So, as I said, I need to hand solder today, which is pretty much what I ended up doing on the last build because I had bad solder paste. I've got a brand new reel of solder. Look at this, massive, which I'm very pleased about. I've got new tips on the iron, which is lovely, and tuber flux. Here it is. The first thing I want to do, I just want to tack this down really. Try and tack it down in one corner. And then we can try and just sort of drag around on it to solder the rest of the pins. Might need some tweezers. Let's get the tweezers. Alright. I'll try and get a set of tweezers that isn't tacky. All my tweezers are a bit bent. I don't really look after them as well as I should. That'll do. That should do. Okay, how's the alignment? Would be good if I could work on this. Probably do the work under the microscope. It'd be easier for everyone to see. Try and drag it over in front of me. That's pretty good. And we can look in here as well. And I'll swap around just a sec. And I'm going to raise this up because it's kind of hard to see everything that's going on. Oh, retro display, that's cool. So, have you built, is it like a kit? Have you built it, or have you bought it and you're just trying it out? Struggling to pick up this chip. Okay, here he comes. These pads are kind of pre-tinned, but something tells me I can't just put hot air on it. I think we're nicely aligned though, that's good enough for me. I need to try and hold it in place. Stick a bit of flux down. This is probably going to move it. And I did spend some time making sure that my iron tip was nicely tinned. I'm hoping we can just get a bit of solder on here. Try and hold this down in some sort of alignment. And just tack it on this side, at least a bit on this side. Okay, I think that's a good start. Hey Data. What's up on the bench? I like that. We're building this ZX Spectrum peripheral. And hopefully it's all going to go wonderfully well. But I'm a bit low on solder paste right now. Yeah, I am also a member of the solder paste crew, but as I mentioned, I bought the wrong paste. I've thrown it out. I ordered some good or better stuff, and it hasn't arrived yet, unfortunately, so we're going to hand solder this. See how we get on. No pressure. I'm going to use lots of flux. I don't really have the ideal tip for this. I'm just using a chisel tip. But if I just stick a load of solder on there, and let's just start giving it a bit of this, eh? I haven't preheated the board or anything. I ended up doing this anyway last time, even though we used the solder paste. Thanks for the encouragement. I think I need it. Let's see. Okay, looks like we've maybe got some bridges, but otherwise I don't think that was too bad. Are they bridged, or is that just shiny flux? I wonder. Let's see. Oh yeah, they were bridges. There. They've consolidated it into a big bridge now. But with a nice clean tip and flux in the mix, I should be able to remove that bridge, as far as I understand. I think the edge of my tip isn't conducting enough heat. Yeah, they never want to move for me, those bridges. Maybe I'll get a bit of wick on it. Bit of a cop-out. I always jump straight to the wick for solder bridges. Let's see. Obviously, I don't want to desolder all that hard work we've already done. Another bridge here that doesn't want to come out. We'll give all the pins a waggle anyway, before we put any electrons into this. We still bridged? Oh no, that's got it. I think that's got it. Ah, I think we're still... might have a little bridge there on the second and third pins from the right. Somebody's actually asked to buy one of these, so I'm going to use this one at the weekend and then post it on, which is quite nice, eh? Is to see what somebody else does with it. Doesn't look bridged to me, that. Let's do a continuity check. You probably can't hear the beeps. So it was 2 and 3, wasn't it? Yeah, we're fine. Can you tell I've got low confidence in my soldering? Looking good. So, this is what I learned last time, is just giving the pins a little waggle. A tiny bit of pressure to see if they move. Is a good way to know if you've at least made a joint. Doesn't necessarily tell you you've made a particularly good joint, but they're all fine. Not a bad start. Oh, let's just move on to the other side. That looks bridged, doesn't it? Oh, that's where I tacked it down. Okay, fine. Yeah, we'll get to that. We'll fix that. Alright, bit more flux then. Bit more flux. Hope everyone's enjoying the nice weather we've been having. We just had lunch in the garden. Checking on the ladybirds. We bought some ladybirds to eat the aphids in the greenhouse, which is exciting. And I think they've settled in. I can't find most of them, to be honest. I think they've sort of found nice places to hide. I need some tip tinner, that's what I need. Anyway, I hope they eat those damn aphids, they're a bugger. Awesome. Tell you what, this flux is a lot better than the flux pens I'm used to using. Which just basically evaporate. Have a little bit more wick in here, try and tidy that up. I should trim this wick down and just use a nice clean bit, really. Hey, chip swap. Yeah, I'm with you. I remember it being quite toasty last year. I am going to trim this down. Got some new side cutters. Look at that. Surgical. Hey Rick. Hey Rick. Next to the weir. Oh, lovely. I'm from Teesside myself, if you hadn't guessed. Smoking wick. Yeah, it's been a bit mixed this week, this last day or two. We've had a bit of cloud, we've had some storms and stuff, but yeah, everything's great. Everything's great. Okay, waggle. See, let's see how these waggle since I wicked them. It's fine. Everything's fine. Cool, moving on. I suppose on a board like this is one of the relatively easy components, even though it's got the smallest legs. It's those passives that are going to be the biggest pain. Here we go then, a bit more flux. Let's move on. What flux am I using here? I think it's MG Chemicals. That's a good one, isn't it? I think. So, bit of solder on the tip and away we go. Try not to melt the packaging, Jim. Not too shabby. Hey, look, I cleared a bridge without using wick. Well done. This is looking good. I think I'm pleased with that right off the bat. Okay, I've already got a bit of solder on this. So if I had some precision about me, I would put a little bit less solder on the tip when we come to do this row. This is totally out of focus. Sorry. That's a bit better. I know it's just a small window, but got a little bit on the tip now, and doesn't look too bad. Hey Data, how's it going? Thanks for that. That's very kind. Thank you very much. SEK, is that Sweden? That must be Sweden, hey? A little bit concerned why the pop-up didn't work. Did the pop-up work? Ah, it does work. Hey, thanks for that. Thanks for helping me, and thanks for helping me test my alerts. You've just shown me that they're not working. I'm going to keep replaying it now, so enjoy that. I imagine you can hear that, can't you? But I can't because I must have my monitoring set up wrong. Let's see. So they are set to monitor. You're just watching me play with my settings now. Hang on a minute. I'd like to get this right so I don't miss things like that, because that would be rude. This must be an OBS setting, hey? Let's see. So it must be preferences or settings. Settings sounds good. Audio. Yeah, monitoring devices set to speakers, so that should have should have worked. Do, 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 do. It's a YouTube alert. Stream elements. Okay, guys, I don't know why I can't hear that. Let me do another test. Try this one. That's someone who subscribed a couple of days ago. I'm definitely not hearing that. I got, hey Rick, I can see your follow from 5 days ago. Look, I should be able to replay that too. The Twitch alerts are always a little bit slow to come through. Bear with me, I'd like this to work. Dee-dee-dee. Okay, I don't understand. I'll have to just keep a close eye on everything. I'll figure it out next time. It's not very interesting to watch me doing this. SEK is Sweden, isn't it? Hey, hey. Where were we? You went to Union Teesside. Oh, cool. Yeah, so my accent is from Redcar. That's very kind. Thanks, buddy. Yeah, Redcar, Middlesbrough. So, if anything, think Vic and Bob. I'm gonna need a bit of wick on here. I have a lot of friends who went to Teesside, and people who work there now. Okay. I'm happy with this. We have a push test. We're not quite central on those pins, are we? But it's not the end of the world. I built, on the previous revision of this, I made an error in the routing and I had to swap one pad to a pin between these two. God, that was painful. Very, very fiddly. Alright, now for these ones then, the 7.4 LS374s. I'll need to get my photo album down. And you can see on the small picture, this is full of chips and stuff. I'm hoping I've got some left, otherwise we're going to have to salvage some off an old board. As these haven't arrived yet either. Let's see. Oh, I've got exactly enough left, I think. It's very lucky. Look, it's a bot. So you know you're Vic and Bob. Check this out. I can get rid of this spam. I should be able to. Wait. How do I do it? I thought I had the power. See, the big streamers, they have their own mods who do this for them. Oh, I've lost it now, haven't I? Oh, here we are. Do I have to go in here? No. Okay, I've missed it. I can normally delete them. Should have come from the Twitch chat, shouldn't it? So there they are. Oh. Okay, there is a moderation tab, but that doesn't help. Ah, whatever. I don't want AI viewers. I mean, at one point, AI is going to get so good that maybe you won't be able to tell. That said, I don't think an AI viewer is going to earn you any ad revenue. Oh, why? I can't let this go, chaps. Why can't I hear my monitoring on OBS? I'm coming back. I'm coming back over. Wait. Hi. Sorry, we're troubleshooting now. So, can't hear monitoring in OBS. In OBS, go to settings. I can do that, that's easy. Click on the audio tab, I can do that. Scroll down to advanced. Find audio monitoring device and change it to speakers. I have done that. That's very easy. Okay. Enable monitoring. Look at your audio mixer. I'm looking at it. Click the gear icon. I've clicked it. Advanced audio properties. Yes. Find your audio source and look on the right. Yes, I've done that. Toggle it down to monitor off. And then back. Oh, this sounds like it's just a bit buggy. Monitor and output. Yeah. Okay, I'm going to replay the last thing. Hey, it's working. I can hear it. Awesome. Right, we're going back. Technical difficulties. We've sorted it out. So. 374. These are the buffer chips. And I have exactly 3 left, which is amazing. I'm going to go for much the same as before. Maybe a little bit of flux will help me tack this in place. Stick a bit of flux down, come on. Don't be greedy. Let's get roughly aligned. Hold it down. Without sliding it around. Oh, bollocks. Let's get some solder on. What is it with new tips? The tips just need to be like broken in, like seasoned. I think that's good enough. So, moving over to this side. Flux, yeah. Here we go. Maybe I need to get a tin of tip tinner. Then you just sort of dip it in, don't you? Okay, here we go. Wider pitch on these, so we should be less prone to bridges. We achieved it. No. No, we haven't. Oh dear. Let's go again. I love that test. That's fantastic, isn't it? What a great little, quick, sensible thing to do. Captain tape. Oh, that's a good idea. Let's see how we go. I've actually got some of that, although I think it's pretty bad, like cheap stuff. Seem to be getting away with it first try so far. Let's just give every pin a little bit of attention. Yeah, I think we're looking a bit better now. Awesome. Other side. Tip activator. What is that, like a tool? Or just like a one of those little Vaseline tins full of stuff? I think this is one of the main reasons that people get disheartened when trying to learn about, you know, how to solder. When the tip's just not playing ball, and it won't tin, and it won't transfer heat. Man, you assume that it's you doing it wrong. Tin of flux and solder. Okay, yeah. Let's see how that could do the trick. I would like these two just to look a bit more soldery. Okay, good. Hang on. Have I put that on upside down? I have. I've put it on upside down. Oh, can you believe it? Alright, let's get the hot air on it then. Oh, what a knob. It was all going so well. At least the microcontroller's on the right way. Okay. Hot air coming in. Yeah, that's correct. I just got carried away. Hang on. Do we have some extra flux? Little triangle is here. That's where it should be. I'm totally wrong. Let's put lots of flux on here. Oh, I need more practice with this. Rework. Could just get a fresh board down. That would be lazy. Hopefully I don't pop the board doing this. Thanks, Derek. That's a great tip. Can someone tell me what I'm doing wrong here? Generating a lot of smoke. He's off. Okay, I think the pads look alright. Get a nice fresh bit of wick. I feel like smashing that much hot air into these chips can't be good. They're only rated to a certain temperature. Hey Wayne, you've done it again. I'm just going to send you an envelope full of cash, mate. Everyone go subscribe to Wayne, please. It's to Retro Robins. Yeah, upside down chip. I know it was very nice and straight, wasn't it? Wayne, you're too kind, mate. How are you getting on with your V drive problem? Not quite got all of this solder up yet. I'm pretending that I'm one of those mobile phone repair people on Facebook here who's really pro, and this is actually 10 times smaller than it looks. Oh yeah, nice and smoky. So, give it a quick clean. Okay, well, recap's always a good thing to give a try if there's some black magic going on. Need a cloth. Let me just get a cloth. Right, it's all gone blurry. Should we try that again then? Yeah, thankfully the crystal wasn't on. Yeah, I mean, we'll be okay. If there seems to be a problem, sure, we could pin it. We could test this. So it has to go on this way, right? Just kidding. This way. The board's nice and tacky now. It's gonna hold itself in place. Got you, Andrew. Alright, let's go again. Rework practice successful, I think. Start by tacking it down. Good. Books. Here we go. Lovely, lovely, gooey, tacky, blowy, fluxy goodness. See, these contacts were all pre-tinned by PCBWay, who made it. I have heard people say that you don't even need extra solder if they're pre-tinned, but I'm not convinced. Now my tweezers have gone all khaki. Let's dip them in the old IPA. That's a bit better. Okay, let's give them a waggle. Feel like I rushed that a bit. Okay. Good. Yippee, Mr. Renew. How's it going? Sorry, I never got in touch with you actually. I was meaning to about the UV boards. And we're building more interfaces now. You know what? I've got nothing against repairing an Xbox. They're getting classed as retro now. What is it, the HDMI port? Isn't that the classic? Did those even have a HDMI port? I wouldn't be averse to doing some stuff on Xboxes and PlayStations, even on the channel, because at the end of the day, it's popular, isn't it? And it's all fixing stuff, which is what we like. Guy at work kept asking me if I'd fix his PS5 with a broken HDMI port, but I wouldn't want my first one to be live ammunition. Okay, here we go. I don't think that's a priority for Crash Live, though. Okay. I already checked this side, didn't I? I was just wondering if somehow I might have disturbed these while we were removing the last chip. No, everything's fine. Alright guys, let's move on. These are all the same chip, and I have exactly 3, so if I did toast that one, it's game over, or we have to rescue one from an earlier board. Get it the right way around, shall we? Oh, I see. Oh, well that's fun as well. Always good to learn a new system. There's a dude I watch who's Toltec Merc. He does a lot of live streaming and he fixes PlayStations. He's really good, really good at fault finding. It's quite mesmerizing to watch. Made me want to get into it. You know, when everything gets a bit small and a bit too many pins everywhere, you need to use different diagnostic methods. I need some solder. You need to get the thermal camera out and get the schematic and just sort of use a bit more logic of where faults may have come in. Seems a slightly different process to what we're used to with these old machines. You're wondering why we're not using solder paste. It just hasn't arrived yet. I'm hoping to have this board running the Manic Miner demo alongside the other board running the Attic Attack demo. Yes, static indeed. Everything's so bloody wet on this board, all this flux. Hoping we're alright. Do. Early start tomorrow as well. Swindon. Why do they choose Swindon? It's 3.5 hours away. I'd like to get there for the setup time, so that means I'm going to be up before 5, I think. Not too bad. I'm normally up for at 6 for work anyway. I'm gonna go sightseeing and see the magic roundabout. No, not really. I feel like this is very slow going. Let's try and speed things up a bit. Go for the next one. This is the last one I have in stock. So that's for the bin. And that's going on there. Nice. Watch me try and... I'm not rushing, I'm just trying to be a bit more efficient. And it's all gonna go tits up now, I guarantee. Swindon is RetroFest. And the YouTube crowd meet up there and have a table to share. So we're gonna, you know, everyone brings a bit of what they've done on their channel, and we sort of rotate it around. Hey Julian, thanks for joining. Welcome back in. We basically turned the Steam Museum into a giant man cave, which I suppose it already is. We were quite lucky last year because one table's not enough, you know, for all the YouTube crowd. Most of the people actually exhibiting are from, you know, computing centres with lots of cool rare stuff to show. We're just kind of hobbyists showing off some bits. But last year, our neighbour table couldn't make it. And that was actually Sam from Look Mum No Computer, which was a shame because I wanted to. It would have been great to hang out with him. He did come and visit though. He didn't exhibit because he was delayed because of car problems, and he visited and had a look around our stuff, which was nice. But it meant we could spread out, and yeah, no one really had to wait their turn, kind of thing, to show their stuff that they brought. This looks good. I don't know if there will be more than one room. To be honest, I've not been that involved in like the sort of all the chat and hype about it. You know I'm going and I'm going to bring some stuff and I'll see you there, sort of thing. I'm happy with that. Okay, we're a bit messy with all this flux, but that's alright. I must get another one of these made because I cocked up this silk screen. That should be PF3 or 1 or whatever it is, and then ground and then 5 volts. So that's saying 5 volts where it's ground, which is a bit of a problem really. To be honest, I think I'll scratch that off because I'm going to give this to someone. I'll probably scratch that off and just tell them to be careful. Let's see if I can find a 74LS02 in the photo book. Otherwise, we might have a problem. We might be back into rework. Ah, I've got one left. Hey, this is very lucky. Yeah, it's an engineering board, but somebody's asked to buy one, which I wasn't planning to sell it because of errors like that, but if someone else is playing with it, then that's also fun. So he's going on that way around because the little bar is where pin 1 is, I guess. Let's check, shall we? Here's one I made earlier. Yeah, hard to see the bar, but it's at that end. Okay. Yeah, that's going to be fine. I only need room for one. Hey Cedar, I only need room for one specky really in a monitor. If there's room to put 2 up, then I'll put 2 up. which is why I'm preparing this, just in case we have the opportunity to spread out a little bit. We'll see. Everything's all sticky. I have shaky hands too. I think as I age, I'm going to get a tremor. I'm ready for that. Here we go. Okay, we are back down. I've got another problem with this board, which is I've dubbed it Spectruino, as you can see. Oh, there's another mess up. D2, I should have deleted that. I've moved it, sorry. I'm not going to have an Arduino chip on it or an 80 mega chip on it in the next revision. It's going to be all Raspberry Pi. Can't really call it Spectruino. I was thinking there's a good pun somewhere in using Pico and then peak like the Spectrum command, and that's exactly what it's doing. It's looking at what's in the memory. Maybe that's a bit of a stretch. Sound as a pound. All right. ZX Pico with a double E. All in block capitals, peak. I'm hoping that the tables will be set back enough that I can hide behind my table and get a bit of space, but last year that wasn't the case at all. There was like a 2-foot wide corridor to shimmy down, stepping over cables and things. Next one. Okay, all our ICs are fitted. Oh, one sec. Hey, my last video was on Hackaday. That's good, isn't it? And if you have Hackaday, I'll go use Hackaday. It's like a blog sort of news thing for techie stuff. I like it when they put my stuff on. It's not really led to like millions of new views or anything, but that is just nice. I know what I've got a problem here. I don't have any more of these, I think. I'm quite sure I don't. Where would I have put it if I do? Hang on a sec. I have ordered some, but mouse haven't turned up yet. I've got a feeling I used my last one of these USB connectors on the last one of these that I built. It's having a rummage. Yeah, this is going to be hard to salvage, I think, because the plastic melts. Where else could it be? I've got some drawers over here. Possible I stuffed it in the headers drawer. If I had one left. unlikely though. Yeah, it's not looking good. Alan! How's it going, dude? Welcome back. Alright, so this might be a bit rough. I've got one here. What's that on it? A hair. This is the first one I made that had lots of chips on it that don't need to be on it. And I don't know how I'm going to do this without melting the plastic. Shall we go with lots of flux? I could maybe try to get some extra solder and sort of bridge the small pins down here. Just absolutely smash loads of solder into there. I don't see this happening without melting it, to be honest. We can but try. I'm just going to hold the weight of the board up here. I've turned the heat down a bit and the airflow down a bit. I don't see that solder melting yet. Everything's getting nice and smoky though. At least I don't see the plastic bit melting. Yaktor, how's it going? Welcome to live plastic melting. Come on, baby. Okay, he's off. Any survivors? Yeah, I wish I had a hot plate. If I had a hot plate. I think he's done alright. Don't you think? The plastic didn't melt. I don't think it did anyway. I've got some horrible big lumps of solder on here now. I should try and get off. Let's get John Wick out. A bit blue tack maybe. It's gonna be hot. It's alright. Focus. Yeah, this might work out. I just need to tidy up a little bit. Without welding the wick to the connector. Okay, that's good. Try not to bend those pins that are stuck in now. Ugh. Blue tack is messy, isn't it? Ugh, horrible. Try and clean it. So there's a little bit of a solder bridge to deal with. What I'd like to know is, have I bridged any of the pins to the case? I think not. All right. So that's going on there. Look how sticky these are. I'm gonna use my hands. I don't think we're in too bad shape there. Need to clean these tweezers again. And enter flux. I do end up kind of just doing these USBs by hand normally, so this should be nothing new. Let's just try and hold it in a good place. Pushing down a little bit. We aligned? Yeah, we're aligned. Hopefully we're not lifted. Hi. Oh, lovely. Thanks, Dal. Love ya. So here we have the Milky Way crispy rolls. Delivered personally. Alright, and the cat's hungry too, so we're all getting fed. Mmm. Delicious. Okay. Where were we? Other chocolate treats are available. Oh god, I've moved it. Maybe I earned that treat by successfully doing a bit of rework. No chip swap. It's not secret. There's I've done a lot of videos on this actually. All of various iterations of it, and I've just put one out yesterday on another project that uses this board, which I'm going to be bringing to RetroFest. This board is essentially, I'm just checking if it's lifted. It's not lifted. Some annoying blue tack in there, but essentially it's an Arduino that goes onto the edge connector, and the extra circuitry, which we're soldering up now, is for latching in. So whenever the specky writes to memory, this will sense it and store, or yeah, it will check the address. I'll read in the address and the data byte that's being written at that moment, and you can write your Arduino sketch as you like to listen for certain addresses. Meaning, sorry, I'm eating. If you know the game code, and for the most part we do, you know, for the classic games they're all disassembled, or you can do a bit of reverse engineering. You could listen for the score, maybe, being stored in memory, and you could put that on a LED scoreboard if you like. Or what I've used it for most recently is you listen to the player health, and if the player takes damage, you set off the rumble pack, and you put a little, you know, you hook up one of the I/O pins from this Arduino to your eccentric motor in the controller pack, and you've got a rumble pack for whatever game you like. That makes sense. Exactly, yeah. Exactly. So it's listening for the room ID and the player position in X and Y, and then it draws you on the minimap. That's where I had to bring in a second microcontroller in the Raspberry Pi to handle drawing that minimap, because this 80 mega chip's too slow. Ooh, I can hardly see this. I'd like to give this a quick poke around and see if these pins are attached. I think they're fine. I want to have two demos at RetroFest. I want to have, I think we've got a bridge there. I want to have the mini map, and I want to have Manic Miner going with the LED scoreboard I just talked about, and the LED strip air gauge. Okay, I need to clean this a bit because I can't see anything. I think I've contaminated my IPA as well here. I'm a bit lazy with it and I tend to dip things in it, which isn't the best way of doing it. I'm just cleaning it so I can see, hopefully a bit more clearly, what our soldered connections look like. Yeah, that's a bridge. Oh, did I get it? I think I got it. We're a little bit wonky there, but could be worse. That one's not connected, that's not connected. So 2 of them on there not connected. More flux. Don't really want to add more solder here. It's just going to make bridges, isn't it? Let's see. I can't tell if they're all bridged now or if that's just the flux. I have thought about that too. To be honest, it's just not something that I'm familiar with at all. So I never sort of decided to explore the idea. That's connected now. That's connected. Connected, connected. Connected. That's not connected. Now it's on. That's on. On. It's all looking pretty good, I think. What I might attempt is a quick continuity check. I need a Twitch Fluke meter emote for this. Ha, do you know what? Because I'm logged in with my private account, I can't do it. I can't do the emote because I haven't subscribed to myself. Oh well, never mind. So, you can't hear the beep, sorry, I've got some noise cancellation on, but maybe you can see. Yeah. Now this is fiddly as, but are these just ground? They must be, because it's beeping. Yeah, I assume they have to be shorted to ground. Let's go with that. Okay, what about this side then? Okay, I think we've got away with that. As long as it's still got some backbone and will take a USB connector, we'll be okay. So now we're on to passives. And I need the schematics for that. Bear me 1 sec. I've got flux on my hands. I need to wash my hands. I'm back. Okay. Hello. Schematics then. Keycad. Keycad's good. Am I in the right one? Yeah, I'm in the right one. Schematics, here we go. So we can refer to this, which is nice. What am I on first? R2, 3, 4, and 5. So R2 and 3 are 5K1, R4 and 5 are 22. Here they are. So these are just on the USB positive and negative data lines. And these are just grounding CC. Okie dokie. Let's switch back over. I can still see that schematic over here. I need again now to rummage through the photo album. And I'm looking for 5K1. Let's start with that. Side down. Oh, well, there's 22. And 5K1. $5K1 is R2 and 3. Okay. Got a feeling this is where I'm going to start wishing that I had some solder paste. Let me just clean the tweezers. I'll try to. without impaling my thumb. Yeah, I have done, not these particular boards, but I did have, I'm bringing these to RetroFest too. These ones reassembled. These guys. And yeah, they did a good job. We've already tried one and it works. Bit too fiddly for me, that. And I am considering it with this, you know, if I get this board to a design that I'm happy with, which kind of seems like it's never gonna happen. I'm on, don't know how many iterations now. Okay. Here comes our little resistor. Don't think these have markings on. Can I flip it? Flip it. Flip it. Yeah. And the other one, no markings. There we go. So I wonder how this is gonna go. Let's have a bit of flux anyway, even though this might get messy. Here we go. Buckle up. Okay, first things first, get you in position. The thing that's going to get me here is soldering the second side and the whole thing melts and comes off and sticks to the iron. But let's give it a try. A little bit of solder on the tip. I've got some 0603 to do on here as well. I don't care that it's a little bit wonky. If I get too caught up with perfectionism here, it will be my own demise. Oh no, there's a big connector in the way. Okay, so let's try and still hold it down. Don't know if I can do this without blocking your view. And this one. Yeah, low stuff first would have been clever. Problem is, yeah, it makes sense for these ones, but for these ones, I could put these on, but then I would be craning over these to get to these pins. I just haven't designed it very well, let's face it. Okay. I'm gonna take my time a little bit, just for the first couple, to make sure there's nothing wrong with the process. And maybe I can do a quick resistance measurement. And what we should see is obviously 5.1, From ground to one side of this. Is it that side? No. That side. Yes, but where does that go? It goes to one of these pins. That one. Yeah, that's one side, and the other side. Okay, I think that's made contact. That's good. So let's move on. Let's do... What should we do? I've already got our 4 and 5 out. These are going to be fun. Okay, well, we'll get it. So let's do our 4 and 5 since I've got them out. These are 22 ohms. And these ones have a marking. That's nice. Very tiny letters. Hmm. R0. It's gonna be fine. Bit of flux. Let's just make sure we're straight-ish before I pin it down. Solder on the iron. Not bad. Go again. Because I don't have the right tip, I think I'm better off. Yeah, touch the top of the resistor first and then sort of come down to the pad. And this is already a bit fiddly to crane over the connector. The next ones are going to be horrible. Well, let's try. I'm still going to hold them down because quite easy to melt the whole thing, even though you're only putting the iron on one side. Floating Fat Man, welcome back. Thanks for joining. How are you? What's going on? Enjoying the weather? I think we just made a connection. Let's see. That one looks good. I wonder if I can do a quick resistance test. Yeah, let's just check it again. Yes, hot and melty. Hasn't been quite so bad, at least today. Alright, where am I going from here then? Read Plus goes over to the 80 mega. Straight in on pins 3 and 4, so can't remember which way around. I'm just going to go with this for a start. So I must be... I need to be here. Looking for 22. Yep, that's one. I need to flip the whole thing around. And I'm on pin 3 there, but I'm not on pin 4. Am I 1? Pin 4, which side is pin 4? There. And I shouldn't get 22 on this side, I guess. Although USB-C works both ways round, doesn't it? So maybe these are deliberately shorted. I think they're fine. Why is it 38.4 on your watch? Where are you? That's nuts. Get in the fridge. Okay, shall we move on to C6, R6, and C7? I can give you the schematics again. We can look together. Southeast UK. Oh, I see. Okay, yeah, that's pretty savage. Well, be careful. Okay, what do we want? C6 and C7. So that's 100 nanofarads and 22 microfarads, and then a 10K. Okay. Let's get the photo album back out. And I'm going to put the resistors back. I'm going to be good and tidy up. Otherwise this will just become chaos. Ah, nice thinking. And then you can use the ice water to make a nice cold glass of juice. Where are my capacitors? Here's some capacitors. So what did I say? I forgot already. Yeah. 22 micro and 100 nano. So here's 22 micro. Um, 100 nano is 0.1 micro, isn't it? So I've got that too. In this one. And then R6 is 10K. I know I've got them. There we go. There's 10K. So C7 first then. C7 is 22 micro. That's this one. Oh, there he is. Where's me tweezers? C7, did I say? Yeah. Oh, it's tacky again. Get off. Let's just have another clean of these. Yeah, I have bought parts from Amazon. I was on last night seeing if I could get some chip quick in time for this. For you know, the solder paste, but they can only sell you the garbage stuff. I wanted leaded, and Yeah. Not so easy to buy these days. R6 is in between, which is 10k. That's handy, there's no marking, so let's not get these mixed up. And then C6 is 0.1 micro is 100 nano, isn't it? I think I say this every time. Okay. Again, no markings. I guess you don't get them on these capacitors anyway. What we're going to test today is this power circuit. I haven't tested this yet. Should be able to run off the specky power and shouldn't need USB once you've got it flashed, obviously. Yeah, it probably would have been. You still have to kind of come in this way to get to these, but yeah, it would have been easier, you're right. Oh, I saw a bridge there. Can I just do a quick beep test? Just over here. Oh, careful, Jim. What are you doing? Yes, they're bridged. Oh, I checked that. I guess I didn't. Hi, you alright? Coming in, here we go. What do you think? Have we fixed it? You need to think of a monster MOSFET. Oh, we're still shorted. Damn, a monster MOSFET project. That's what you need. Okay, let's just keep these in the right order. Just get them out of the way of what's going on here. That's still bridged. Bit of flux. Oh, I picked up a capacitor. Hey, stay there. Okay, let's throw a load of heat around in there. What was that sound? I guess it was just in the audio track. Is flux conductive when it's wet? No, maybe not. Still bridged. Technical difficulties again. Maybe we need to bring the wick in Now I can't tell because everything's wet. Let's see. Turn it this way. Still getting continuity. Pretty certain I'm not supposed to be. Let me just look on the other side. Yeah, definitely not. John Wick can sort out any situation, can't he? Damn. I can see it. I can see that it's bridged. What if I'm going to have a bit of a Dr. House moment here. I'm going to put solder in. And then I'm going to get the wick on it again. I'm trying not to push too hard as well to bend the pins when they do desolder. Okay, it looks good from this angle, at least. I can't read it. What have we got? Subscription. Now I don't know if my mood's in the chat or not, so because like, these come up even if it's just a new subscriber from a video. That is still shorted. Yeah, I find going into swearing mode is therapeutic, but yeah, it doesn't get the thing done in the fastest time. Might end up being a frisbee yet if I can't sort this out. I've stuffed a load of solder on and it's all bridged now. Which is to be expected. I think we need some more flux in here. It might end up being a very ineffective coaster. Trying to do this all, keeping it in the shop. The wick doesn't really get under there. Ooh, what do you think? Have I done it? I know this is painful, but at least we spotted it. Hey! We got it. Rock and roll, okay. Moving on. And these three, I think, are still in formation. Something tells me these tweezers are going to be tacky again now. I think this can be upside down. No, I don't think it can. Wicked. So, onwards. I'm not looking forward to Z1 and Z2. Okay, yeah, I'm just reading that, Julian. That sounds like a good routine. Yeah, it doesn't. It does really get hot, doesn't it? Up at the spool of the braid. What happens with me though is, if I'm getting the wick out, something's gone wrong, and that means I'm already in a biff, and I don't have the patience for that. That's something I need to work on. This is one of those hobbies where the only way to get out of a frustrating situation is to be less frustrated and meditate and take your time. I don't mind doing this stuff on, you know, when I'm chatting to you guys. This is quite nice for me. I like that I've got, you know, when am I finishing? 7? Yeah, I've got 3 hours now just to build this and test it, really. Like, this is the main objective. And being on with you lot, it slows me down. Okay, you're not going to see this because I'm soldering over this USB connector, so bear with me a second. I guess you can see on the picture-in-picture. I at least have some good solder to work with now. I was struggling previously with some crap solder. Hey, I can't read that, but how's it going? I'm not totally convinced by C6. Will I see it wiggle if that's not... Alright. Maybe we're on. I can always beep it, I guess. Where does C6 go? C6 goes to F1 and ground. That's easy to test. So this is the resettable fuse. That's beeping. That's good. And this is ground, and that's beeping. That's good. R6. R6 goes to ground and 5 volts. Ground is beeping, 5 volts. It's going to be over here somewhere. Isn't it? Wait. Okay. Trying to remember my own schematic now. Oh, the diode. Of course. I'm not getting a beep. D2. This is D2. Should connect. Oh yeah. Yeah, that's good. That's made. And C7 is again between the fuse and ground. Hey, the battery died. Sorry, one sec. And I bet we've lost focus. Yeah. So, fuse and ground. So here's fuse. Do that side. Aha. There's the fuse side. And that's the ground side. Awesome. Should we do these 06, 03s then? So this part is CGO 603 MLC. Let's see if I can find it. 5E. Where is it? CG0603. Not that, not that. Hope this isn't one that I've run out of. This could be one that I've run out of. I've got a feeling though we don't need this part for it to work. Oh god, I haven't got it. Right, let's have a look what this even does. So this part isn't. Hello. Oh, more food delivery. We got a Coke. Hi Taz. I know I've got all my computers on and that. It is hot in here. She's right. Okay. So I'll show you the parts we're looking at. These two. CGs. Variable resistor. I just copied this off the Arduino micro schematic, by the way. It's a varistor. Did anyone good at USB? Why do we need that on the data lines? Does it matter? I guess it's a pull down. It must be a pull down. I'm gonna ask AI. It is a electrostatic discharge suppressor varistor designed to protect your device from voltage spikes. You can't use a resistor. Okay, fair enough. Leave it unpopulated. It will work. Okay, I'm gonna listen to AI. Oh, hey. How's it going, Mahmood? Yeah, we saw. Hang on, I can replay it. Here we go. Here's your pop-up. It's behind. There it is. Oh, there's me. I'm going to leave it unpopulated then, when that means we don't have to solder 0603 parts, which is good news, right? AI is not always right, but AI sometimes tells me what I want to hear. In fact, it does that a lot, doesn't it? It's not very good. Alright. Let's scoot back over then. Oh, what a shame that we don't have to do the 0603 soldering. But what we can do is tidy up a bit. I'll put these capacitors back in the capacitor bit. Give the photo album. No, that's the resistor bit. Not bad. Hang on. This is where capacitors go. Oh. Tidying up. Capacitors back in. How do I get the feeling I'm going to need these parts again in a minute? Right, we don't need the varistors, which is nice. But we do need a fuse. So where's my fuse? Resettable fuse. 750 milliamps seems fair. For the onboard supply. Although, I suppose you might come up with something you want to use this for that is more hungry than that. But in that case, you'd need to power it differently because you don't want to pull that much through the 7805 on the Specky, which is the purpose of this. So that goes there. Hi. Yeah, how long? My PCBware rule is about to be used for baking. I haven't used it. It's alright. Right. You can rinse it. That's alright. There's some yoga retreat cooking happening in the kitchen. We have a varied household. Fuse. Okay. Where were we? Let's do some more building, shall we? Looks. Get this in the right spot. Send those rulers out left, right and center to all the people that they sponsor. So I think basically every YouTuber at RetroFest probably has 3 or 4 of them. Pretty good, eh? I'm pretty happy that fuse is fine, isn't it? Okay, we're not doing the Z1, Z2. Stream stopped. Did it really? Let's investigate. YouTube's telling me the connection is excellent. But I can see that the view count dropped to 3 for a second. I wonder if It does have a nasty habit of just cutting off and starting a new one. Let's see. Oh, thankfully it hasn't interrupted the stream completely. Something's happened because, yeah, I can see the view count dropped. I don't know, it's probably something I've done wrong. I'm still figuring all this out. So what about voltage regulators? I haven't tested this function yet. As in, I say function, I haven't tested using this purely off the specky power. I've just been powering off USB. But I do have these regulators. And this is should be a 5-volt regulator, which is attached to the 9-volt supply. So directly to the plug going into the back of the specky. This particular one has a maximum current of 300 milliamps. And this isn't particularly ideal because you could easily envisage wanting to use more than that, but I can't find a small voltage regulator for 5 volts that fit in this footprint that can deliver more than that. So what I'm hoping is that what I'm at least demonstrating at RetroFest isn't going to exceed 300 milliamps, which it shouldn't. It's just a load of LEDs, and that's just a load of LEDs really. And I'll have to come up with a better design for the next revision, which uses a bigger regulator. So let's try and get this ground tab down anyway. How did my solder get separated? I'm using a free length of solder here now, so something's gone wrong somewhere. I must have put the soldering iron through it. Let's have a bit more. This ground plane goes all the way underneath the chip. Is that on? Yeah, that's pretty on there. I wonder if this is going to work. I hope so, because the power circuit going wrong is the kind of thing that can just fry the whole board. It's not a complicated design, it's just 9 volts or whatever it is you're stuffing in the back of the Spectrum comes off the edge connector into this regulator, which spits out 5 volts. 5 volts goes through a diode to protect if you plug the USB in while the specky's off. And the 5 volt output of this is directly connected to the USB 5 volts. Because I'm just hoping that the USB port on the computer can deal with that, which it has done on previous boards I've made. So first question is where are my tweezers there? Yeah, that's all looking good. Let's do C8. C8 is a 100 nanofarad smoothing? Seems quite small though. Smoothing capacitor on the output of the regulator. 0.1 microfarad, that's what I said, isn't it? Sure, I would have got that off the data sheet. So this is 0.1 microfarad. Plop. There's enough flux going around there. Let's just get straight to it. Let's just align a little bit up. Yeah, that's good. It's so nice having 0.5 kilogram fresh reel of solder. Yeah, good solder as well. I've actually bought 1 kilogram. I've got 500 grams of leaded, 500 grams of unleaded. I should be set for quite a while. Looking good. So now we just got this big fat diode. Got some over here. The size of that. I hope it's the right one. I haven't marked the polarity, so I'll just check the schematic quickly. So the side with a line should connect to 5 volts, and the other side should go to pin 1 of the voltage regulator. Let's just get the scope. Luke. So one of these, well, I can see it connects there. Is that really connected? Yeah, it is. So that side is that, and this side is 5 volts. So yeah, side near the edge connector. Which means I dropped it the wrong way around. It'll be that way. Flux me up. Flux is fluxing great. It's all wobbly. Sound. On the other side. Let's flux it up. Probably don't need to hold this down like that, but can't really tell if that's gone on very well. It can feed a bit more solder in. I think that's good. Well, the pads are pre-tinned on this PCB manufacturer, which is what's making me hope that I'm getting good connections made underneath the pins as well. I have done that before though, like tin the pad and then sort of try to heat it and put it down, but I don't know what's best, to be honest. I'm not the expert on this. If it works, then we'll be happy. So all we need to do now is the little clock circuit. What's that made? That's moving. In a minute. Case in point. What else looks suspect? I think we're all right. Just lost connection again. I hope we're still online. I think we're still online. I got a little bing bong from the PC saying we'd lost connection. Just nod if you can hear me, anybody. Thanks. I've even ran an Ethernet cable through the house for this. Alright, I'm looking for crystals. Crystals, there's a crystal. Last one again. I'm very lucky here. Cheers, Rick. Da-da-da. Crystal. This might be interesting. I don't think it matters which way around this is. I think I will just compare with this one, which I know works. I think it's actually the other way around, isn't it? Yeah, it is the other way around. Oh, it skipped it. Okay. I don't know if that's me or my internet provider or Twitch or YouTube. I don't know. I think streaming to two places at once is very, very bandwidth hungry. Okay, this is going to be interesting. Let's see how we go. Two and a half hours to go. I think we'll get this up and running, hopefully. Oops. I need to do this in a way that will give me enough exposed pads on this side to make the joint. I think that's alright. I've just tinned C1. Didn't mean to do that. Don't look, I'm not cutting the braid off. More flux. I don't know if I'm making a good connection out of that. I think it's because of the chisel tip. It isn't really getting in there. I don't want to... If I try and feed the joint, I think I'm going to move the whole component. Oh, that seemed pretty good, didn't it? Feed the joint. Not too sure about that one. Oh, it moved. Okay, it's okay. It landed in the right spot. Interesting. I didn't mean to tin this bit. Suppose I could just throw a bit of hot air at it, couldn't I? Should we try that? I know we were just talking about how sensitive these are to hot air, but maybe I can just get the solder to melt. Of course, the melting point will be high now. Maybe I'll slap a bit more flux around. This is probably the one bit where I would have really liked having that chip quick. Maybe we can just get it to glide. Doesn't want to glide. Oh god. That was clumsy. I think I'll give up on that line of inquiry. I don't want to damage it. Let's go back to just trying to get each corner made. Wish I had some solder paste. I need some more flux, I think. might be there, you know, I don't know. Just try and get a blob of solder on the very end of this tip. I can just poke it in. Solder tends to want to hang on not to the very end of the tip though. It sort of slipped into place quite nicely. This is the 80 mega chip here, yeah, the big one with lots of pins. And this is the clock for it, because it's a microcontroller. It needs a clock. I'm struggling a little bit to do this crystal by hand. Let me look at the schematic, see if there's a way I can test with continuity if I've made it. Not really. 2 of the pins got a ground, and 2 of them are connected to the load capacitors, which are the capacitors you can see either side. So the case is connected to ground, which means it has a ground connection, which is good. But whether or not we've got these connections to the load capacitors remains to be seen. Now we get continuity for these pins of the load capacitors because they're connected to ground. These ones should be connected to the pads underneath. We do get a beep there, but it's obviously because I'm just touching the pad. I wonder what sort of... Should you be able to measure resistance over a crystal, do you think? Look at one I made earlier. So, ground, fluff. So what fluff? What about... 14 mega ohms. Basically none. From there to there. 14 mega ohms though is the same. Are they connected to anything else? Yes, of course they are. They're connected to the microcontroller. So that reading is through the microcontroller, obviously. Okay. I guess all I can do is just... if I can make it look visually compelling, I'll be happy enough. Which means if what I mean by that is if I can just... I'd like that joint to look wetter. Yeah, like that. Now, I guarantee this is where the whole thing moves. What I definitely don't want is the solder to short that pad up to the casing of it. I need to be very careful of that. Then the whole thing won't run, and that's a guarantee. So, ground. Now that's not beeping, that's good. That's not beeping, that's good. Yeah, okay. Right, let's continue. We can always put a scope on the clock pin. Say the clock pin. There are two crystal inputs on the 80 mega. We can probe them and see if they're wobbling. So let's just tidy this up again. Okay, load capacitors are, back to the schematic, 22 picofarads. Oh. So let's have a look. With any luck. Here we are, 22 picofarads. These are white. Get 2 of them in. They're just white all the way around, so before anyone tells me I've put them in upside down. My tweezers need another clean. Oh god. Get off. Good. Haven't fully cleaned the solder off that joint, but it's gonna melt when we attach that capacitor. So here we go. So we need to hold it down, and I'm probably going to need to maneuver it a little bit. That looks good to me. The AT Mega needs them, I think. I don't think it has them internally. I have copied the Arduino micro schematic. Everything around the chip. So I've basically just deconstructed and reassembled an Arduino micro on this board, and it did need them. I'm very happy to be corrected though. Oh, I see what you're saying. Sorry. You mean the crystal? I don't know the answer to that. Let's have a look. So, let's see what part I've got here for the crystal. Back, let's look up the Arduino micro schematic. So, this is the schematic, and it won't let me zoom in. It must be fully zoomed in. But yeah, crystal here with 4 pins, two of the pins to ground, and 2 here to crystal 1 and 2 on the AT Mega. And then you got these two 22 picofarad capacitors. I just copied that. So in terms of the part that I'm actually using, I'm Let me find the actual part. On Mouser. Might need to bear with me 1 second. This one? Yeah, here we go. This is the part. It does have a load capacitance rating. That's the internal connections according to this. Yeah, okay. So I guess what you're saying is I could have achieved this with fewer parts if I replaced that with just a 16 megahertz oscillator. Doing a bit of Googling around now. Anyway, I learned something today, so that's cool. Yeah, so I mean, I just kind of, I was a bit dumb and I just copy pasted the Arduino micro schematic. Okay, with any luck, that's fine. I'll just beep test to make sure I've made the connections. Yeah. Hang on, that's the ground one, wait. Yeah. And then this one. Hang on, which one's ground? That's ground. Yeah. Yeah, we got the connections, that's good. Cool, so we're nearly there. Clock circuit's in. We've got 1, 2, 3, 4, 5 more passives. And we've got headers and a switch and an edge connector. That's all display. Yeah, whoops. So C3, 4, and 5. Whatever you're into. Flip swap. That's what I say. C3, 4, 5. On the schematic. C3, 4, 5. Let's see. 1 microfarad, 1 microfarad, and then C4 is 100 nanofarads. All right. 1 microfarad. And 100 nanofarads. I knew I'd need that one back out. Passives. Did I say 100 nano? Yeah, and that's 0.1 micro, so we'll have this one out. And here's 1 microfarad. These are the big fat ones, yeah. 1 micro. So 2 of them are 1 microfarad. That's C3 and C5. I like these because they're sort of square, big cuboids. I must clean these tweezers again. So that's C3 and C5. There and there. And then C4 was the 0.1 micro. That's these ones. None of these are marked in any way, so let's not mix these up. C4. Okay, flux. Language. Sticky, tacky, flux. Get on. Get on. Yes. Start with these 2 babies. Need 2 hands to get this in the right place, I think. Good. Oh, I moved it too fast. It was still setting. Freezing. Yeah, good. Not the straightest, but it's on. No, man, no. Thank you. And these other sides, let's go. This one is quite wonky. I apologize. That made? I think it's made. And this one. Oh, lovely. You get to watch me try and find my microcontroller programmer again. I think that's fine. So that just leaves R1 and D1. Then we're on to through holes, which is bread and butter really, isn't it? R1, I think is, yeah. R1 and D1 are just the reset. circuit. So, where does that go? Oh, that goes to the header for programming, of course. 10K. Back into the photo album. We're looking for 10K. There we go. I seem to remember that I don't quite have the right size diodes for D1, but let's see. I just used a 4148. This one? Yeah, these ones I was using. Plonk him in there. How are we doing? We've got 2 hours left. I think we're gonna have plenty of time to get this running. As long as we don't have technical issues like we did last time. So this is our 10K resistor. Oh no, I've got all tacky tweezers again. Drop it. Drop it. Oh god, this is diabolical. Hang on. Drop it. I'll clean these again. Alright, let's try again. Dip them straight back in the flux, that's good. Please turn over. Turn over. Turn over. Oh no, polarity. Oh god, I can't even. I'm getting another one. I didn't think about polarity. Where's the bag gone? We'll go in pear-shaped. Magnetized. Maybe that's what's happening. Okay. Polarity. Now, I'm not going to be able to just look at the other board for this because it's going to be it's going to be invisible. I have to use a schematic, but God, these are small. You can see the line on it though. That's good. Got the schematic. I mean, this should be obvious really, but so the line connects to 5 volts. Fine. Get the fluke out. And one of them should connect to reset. That's that one. That means that connects to 5 volts. Yeah, and I just said the line connects to 5 volts, didn't I? Look at me saying line, because I don't know if it's what the proper word for it is. Yeah, line to 5 volts, so line down. So I need to swizzle him around. I'm going to give this a good brushing, this whole board, because it's very goopy. Look at this stupid package. Silly. Flux. Flux. I didn't fit R1, did I? I just knocked that and thought, oh god, I did a very bad job of soldering that one. And we don't care about the direction of the resistor. Right, let's align again. Sound. Tiny bit of solder. Yeah. I'm fairly confident that's a good connection. Sound. So that means we're just on through holes now. I think I'm gonna get this microscope out of my face. We'll go to the macro lens and find some headers. I've got my switch ready. There's the switch. Might as well get on with the switch first since it's here. Look at those lovely traces passing through. Yes, it is. Yeah, I'm bringing both of them. So this one's finished, and that's going to be running one demo. This is going to be running another demo. It's just the most interesting thing I've done recently, I guess. Apart from building the Amiga, but there's going to be a trillion Amigas there. I've got a bag of 3x2 headers somewhere. I was hoping I'd find one in here. Oh, there's one, look. Perfect. I'm going to try and do this without blue tack because I hate blue tack. That's pretty good. And then this one, somebody's going to buy off me. I had a request for one once I've finished with it at the weekend. I wondered if I'd get 2 of them built today with you guys, but I don't think that's realistic. It's taken a bit longer than I expected. So that header will allow us to program the ATmega with the Arduino bootloader. That's important. And now we just need 2 Boggle pin headers. appear to have inadvertently filled this ground pin. There we go. I forget. Actually, what do I need? I need a 1, 2, 3, a 7. 7 and a 1, 2, 3, 8. Okay. No problemo. How big is that one? Is that going to fit? Oh, that's an 8. That's handy. Oh, hang on a minute. Aha. Female. Female. Let's see. I might be cutting some headers down here. Let's see. Don't worry. Then this one isn't moving on till after RetroFest. An 8. Yeah, that's an 8. I've got more boards. I can make more, and then the boards are available. I'm just not bothered about getting this particular revision out there because it's got problems. And I know that the next revision is going to be wildly different. And much better. These silly big socket legs are just heat sinks. We're also going to need to solder an edge connector on. Which is a smoky good time. The edge connector is such a sting in the tail with these because you spend all this time building everything, like, yes, I finished it, and then you go, oh god, the edge connector. The biggest, most painful bit. Okay, that's good. Now I don't think I've got any 7x1s out of the bag. No, certainly not. So I'm gonna have to try and cut this and see how that goes. How did it go? Good enough. Are we straight? I think we're straight enough. This is ground, this one, so it's going to need a bit of heat. I think it's gone okay. Lovely. Alright, let's trim these down and just give them another quick once over. I feel like I'm covered in flux. Right then. Another quick touch. That just leaves the edge connector. Where are my edge connectors? I hope that this contains a lot of edge connectors. Oh yes. Lovely. Tons of them. Yeah, final furlong. Now, I'm famous for soldering the edge connector on the wrong end of the board. Luckily, I've got one right next to me to compare, so I can't get it wrong. Yeah, these pads are too big, and for some reason when I first imported the footprint to my keycard, I increased the size of them. I don't know why. I thought I'd want them bigger. Just had to open the window. I'm rafting. Okay, and off camera I'm trying to bend these edge connector pins in, which is not a graceful task. Yeah, it's still not enough. Doesn't take much force to bend one pin. It takes a lot of force to bend 28 pins. Okay, I'm just trying to wiggle the edge connector in. Without bending the pins laterally, hopefully. Wiggle, wiggle, wiggle. Okay. Yeah, we're on. So what I'm going to do now is go blind from inhaling solder fumes. At least they're all just touching the pads with their toes. Right, that's one on, and it's not quite straight, so let me just try and make sure we're straight. You reckon? Are we straight? It's got a bit of wiggle in it still, so let's go to the other end. Wow, that really didn't take. Okay. I think it's straight enough. Was this one any better? About the same. I'll tack down the top corners as well. Yeah. Looking good. Now we just have to run along and get the job done. Without introducing big solder bridges like that. I've never done that before. I just put too much on. Oh, where's the wick? Top. Okay. Crisis averted. Moving on. Can't quite put my head over this because the camera's there. You can see how these pads are way too big. It is good to have a lot of solder, I guess, because you do need a lot of mechanical strength out of this edge connector. And it all comes from these solder connections. You can get edge connectors which oh, good spot. Thanks. I was just focusing down a bit too much. Should be fine, thank you. Good eyes. Yeah, pretty surprisingly strong. Once all these 56 or so connections are made. Okay, wicked. That's one side down. Because the spacing's so thin between the pads, it's impossible for you to see on that on that feed, but I can't really tell if there's any shorts, so I'm just going to quickly... Good. Top side to do now. And then we can program it. We could program it now, but it'd be nice to get the iron switched off. That was a blob of flux which was just sitting there that had fallen out of the solder core. Possible? This reel of solder I bought is so big, it doesn't fit in my solder drawer. I'm a little bit upset about. There are worse problems to have. I think that's it. I'm going to inspect to see if none of these have lifted. I think we're good. There it is. Right, I'm turning the iron off. I'm going to tidy up a little. Very optimistic turning the iron off at this point. And I'm going to need a USB cable. I have one here. Oh yeah. I was thinking you could use this, or at least the next version, to get the HDMI output. So that's good. The USB feels good in that port that we borrowed. And I plugged it in and nothing's blown up. Can't remember if I need it plugged in to program it though. I don't think I do. I do need a USB ASP. This is the most exciting part of the evening. Me looking through my drawers. Don't understand how I keep losing things. What would I have done with it? I would surely have put it somewhere very, very sensible. Since I had such trouble finding it last time. Where should a USB ASP be? Bear with me. Found it. Oh, well, now we have to program it. That's where this thing comes in. And I just plug this funny board in there. And then the USB goes in the PC. I need to use an extender. As so. Tell you what, shall we go wide angle? Close your eyes. Okay, so. There's our USB going into the PC. And it's recognized a device, which is good. And I can actually program it using the Arduino IDE directly. I'm gonna share my screen. Bit small. So if we go Tools, Program a USB ASP, Board Arduino Micro and Burn Bootloader, we get an error. That's a good start. I wonder if it does need power as well. Let's try adding some power into the mix. And now you can't actually see the menus. Burn bootloader. No, it's failing. I'm getting these errors again. It's not happy about something. And this is exactly the setup I used last time I did this. The jumpers are set. Let's give it another try. Yeah, something's not right, unfortunately. And I don't know what. Everything is connected correctly. We may need to go around waggling pins again. Well, there is 5 volts on here. That powers the board. I can definitely power the board if I use a phone charger, so I'll plug that in. Okay. Board has power now, assuming that USB socket's working correctly. No, same error. We did have this last time we tried to do this. And one of the pins wasn't soldered. In fact, multiple pins weren't soldered. Maybe we should just have a little waggle around again. I was also suspicious of clock. Soldering around the clock. Coming in a bit closer. Should clean this board too. Very fluxy. Now, I'm happy with all those connections. So that's not the problem. Let me just give it a quick clean. I'm interested in the clock signals. I wonder if I could probe the input pins on the AT Mega with the scope. Power that up and I'll get a jumper wire in. To give me ground. This will do for ground. And the pins. Oh, you can't see anything. Hang on. Sorry. So the pins for the crystal inputs are 16 and 17. I don't know which way they count on an AT Mega. Let me just check a picture. So they go anti-clockwise from pin 1. Hey Doug, thanks for following. Let me give you a pip of the scope. here's a theory. If I power the board, and I find in 16 and 17, did I say? Yeah. I think there's 20 on each end, isn't there? Or is it 22? 22 on each end. No, that's wrong. 11. There's 11 on each end. And we want 16 and 17. So 1, 2, 3, 4, 5, 9, 11. Hey Doug, thanks for subscribing. There's an easy way to do this rather than probing the pin on the 80 mega. I can just probe the load capacitor. Let's fit that. Interesting. I'm convinced by that. Not that one. I don't know what these waveforms should look like, if I'm honest. It's doing something. Doesn't look right to me. I can compare it with this board. Let's power this one. Looks a bit more clocky, doesn't it? They both look like that. That's a working one. And let's look at this one again. Doesn't look right. Doesn't look right. I wonder what I've done wrong. I'm gonna look at the other one again. They look like clocks. What do you think? A bad cap? Maybe I just need to try and touch it up with the iron. Could be the crystal. We did put some hot air on the crystal. Might not have helped. Just scooting the microscope back in to play. I don't have another spare crystal. I could pinch one off this board, which we've been pinching crystals from. But I'm not convinced yet that this crystal is necessarily bad. It might just not be soldered in correctly. Kind of tricky with the crystal in place, with the capacitors in place now. They're coming from the side. Cannot get these joints to look convincing. Those joints under there just don't really want to take anything. I don't have any solder paste. I think I can easily remove it because it will just sort of fly off if I put enough heat into it. He says. Need more flux. I think we're going to be taking that donor crystal at this point. Where are my tweezers? Something doesn't look right there. I think a pad came off. Get some wick. Okay, where's our donor crystal? I wish I had some new crystals, but I don't. This one. More flux. I honestly thought this would have lifted out by now. I'm worried about using the heat gun because I'm worried that the heat gun might be what damaged it previously. Let's see if this gets it. It should be pretty toasty in there by now. Let's have a flux top up. Okay, he's out. Yeah, sorry, I think I'm being a bit impatient with it here. That's a good idea, that would have helped. I've got tacky tweezers again. We're back in the same situation of having to try to solder this thing in place. Can try and get it to stick down with just the tin on the pads and the residual solder, but I don't want to melt my connectors here. That looked pretty good, didn't it? Connectors are taking a hit there. We might have a connection there. Oh, it looks kind of not wet enough. But it doesn't hurt to plug the USB in and see what the scope's saying. It looks the same. Oh, that looks more like a clock. And that one doesn't. Should we see if it programs? Hey, look, it's burning the bootloader. Those errors threw me once and I was still chasing faults, but cannot set clock period. It's just an error that shows up, I guess. There's the progress. I think it's worked, guys. So now, now I'm going to plug in directly to the PC's USB port, and yeah, we did get a bing bong. We got a bing bong, but we also got an error. Let me take the USB extension out of the mix. I'm getting USB device not recognized. Yeah, that's not right. USB device not recognized. So we must have a good connection to the programmer header pins. But it looks like we must have a problem with the USB side of things. I know that this connector took a beating when we salvaged it. Is that a solder bridge? You can't see, sorry. I don't think it's a solder bridge. Let's just do a bit of waggling. Oh god, look at the state of that. Focus. Does look a little bit melty, doesn't it? Melty is never good. What is all this? That's flux, isn't it? Oof. Well, connections appear to be made. I can check for shorts. Everything looks correct there. Yeah, that all looks fine. What is the path then of these signals? So positive and negative data pins. There's one on each side because it works both ways. And they go to R4 and R5, which are over here. So R5 is positive, so that's a positive pin. This is R4, which is a negative pin right next to it. Yeah, and then we should have 22 ohms. Well, it'll be less because it's in circuit, but no, it is 22. 22. And then they should connect to pins 3 and 4 of the AT Mega. So I'm going to go over to 3 and 4. Doesn't quite look right actually. So hang on. Wait. 22. 0. R5. R5 is... R5 is the positive. So we've got 0 ohms from there to that slightly darker pin. And no yeah. Oh, this one. Yeah, the regulator's not part of the system at the minute, but that is soldered. So that's 0 ohms. So it's 22 ohms to the other side of R5. Now, if I just keep that on that positive pin and come over to here, I should get 22 ohms to pin 4. And I do. and then pin 3 should connect to that one. Something's not right there. That connection's not made. See it moving? Did I just totally fail to get round to soldering R4? That's definitely the problem. Just getting the iron hot again. I knew it was optimistic to turn it off. Time is it? 6. I've got an hour. Okay. R4, here we go. That'll be it. Let's plug it in. Oh, I still got USB device not recognized. Maybe I'll reburn the bootloader. Okay, it's plugged in, it's powered up. It's burning the bootloader again. Takes a minute. Done burning bootloader. The reset button works now. It resets the chip. But I'm getting USB device not recognized every time. It seems to be cycling. A little bit frustrating that. Why doesn't it work? It used to do this thing where you get a USB device not recognized if the microcontroller had got locked in a funny state. Might not have any more bright ideas. The only difference between this and the other one is I've fitted this diode and regulator, but by the schematic it shouldn't really make any difference. I've checked all these pins are soldered correctly. We could take a look at what the data from USB looks like. That looked square, didn't it? Oh, we're getting square volts. Yeah, thanks for subscribing. Again, you can't see. Hang on a minute. Sorry. So I'm on pin 3, that's one of our... So there's some square waves. Sorry, Derek. It seems like the USB is getting through. We can look at the clock again. Looks clocky. Yeah, our clock is clocking. I don't know what else to check. The USB signals are getting through. It's got a clock. What more does the ATmega care about when it's just initially plugging in? We can check it's 5. There's a 5 volts. Hang on, that's not 5 volts, wait. Sorry. This one. This one is 5 volts. Yeah, it's a bit wobbly, but it's close around 5 volts. I think there's another 5 volts there. Yeah, 5 volts. The reset pin is the second one in. Oh wait, that is reset that I just probed. And then I can pull it low, yeah. So that means that this one should be 5 volts. My apologies. Yeah, it's about 5 volts. There's another 5 volts on pin 2. Yeah, it has 5 volts. And then we've got our USB read on pin 3, which we've seen does oscillate. The scale's not right at the minute. Pin 7 should be another 5 volts. 2, 3, 4, 5, 6, 7. Yep, 5 volts. What U cap is. Then you got your SCK and your MOSI and everything down this end. And they won't be doing anything right now. I'll just try plugging in the other board. Make sure there's just nothing funny that my computer's doing. Yeah. The other board's happy. Oh guys, I'm afraid I'm clueless on why that's not detecting the chip. If anyone's got any ideas, let me know. It's a little bit frustrating. I'm just going to Google quickly if anyone's got any tips. Double tap the reset button quickly. Don't know what that does. Let's see. Can try it. Doesn't seem to be doing anything. Could try flashing it as a different board, potentially. I mean, you can't see, but it does give you options. But I have been using Arduino Micro for everything. I don't think it's going to be anything to do with how we've burned the bootloader, because I just don't believe it would have gone in. I say the only difference between this and the other board is the power circuitry that I've put on it. Which is the regulator and this fuse. Guess it doesn't hurt to remove them. Let's get some hot air out then. We'll remove the regulator for a start. I like trying stuff for the sake of it. I can look at the USB signals. I don't think I can like capture a trace of it very easily. That regulator soldered itself to my microscope base. I mean, I could put the logic analyzer on. That's ugly, but at least it's dry. Let's just plug that in. Yeah, we can try scoping the USB signals on the working board. I'll just try plugging this in now. Yeah, that's got the same problem. I suppose as expected. Ah, you're right.
Use the pastry scraps just shape.
Oh, thanks.
Oh.
God.
Oh,
Cheers.
okay.
Sorry. Okay. Let's look at the scope then. Scope is still on the screen, isn't it? So. This is the quote, good board. Yeah, the old board I tried connected and it works. I'm plugging in the working board now. Okay, that scale should be fine. I set something up wrong here with this scope. The trigger's not on. Is it the scale? I don't know what scale I should be looking at here. Time scale. It's kind of pulsing, like. Okay, I've got it triggering now, so it's seeing these pulses on each one to about 3 point, what is that, 6. Doesn't like having the scope on. I'm plugging in the bad board now. So that's one of them. It's sort of weirdly moving around up there at 3 to 3.5 volts. You can see it. What is that sort of ripple up there? It sends bits when it's trying to connect. This is the other data line. It sends bits. I wonder if it could be those varistas. You remember, we've got these tiny components which I thought we'd get away with not needing. But I can pinch some off here. Hi sir, how's it going? I don't know, it's in a USB 3 socket. I don't know what the AT Mega does. I'm going to take these varistas off. I know that we thought it would work without it, but maybe we do need to solder these tiny components after all. I have to do this without losing them. I think I'm going to have some extra flux on there. These are on the Arduino micro schematic. Not giving it up. Alright. That's one out. Oh, I see, okay. Yeah, I thought that too, but I'm running out of ideas. As far as I'm aware, I've built these two boards the same. And I think I've lost one of the varistas. Oh god, where did it go? I've got one here. If I've pinged that off, I'm never going to find it. Well, so it's a new chip, and it went on without too much trouble. There it is. The socket might be dodgy. I'll give you that, because we had to harvest the socket. Yeah. Yeah, the only thing I'm seeing differently is that sort of ripple. Oh, hang on, wrong board. This is the one. Can't think where the ripple could be coming from. Everything's getting a bit sticky. That's one in. Could be the connector. This connector's had a hard time. I've got new ones in the post. Capacitors. There aren't any capacitors between the connector and the chip on those lines, as far as I can tell. This is going to be awkward. I need to come down quite steeply. I can choose whatever ground I want. So I could just put the ground to something else. Ripple on the 5. Yeah, the 5-volt supply was moving a bit. Let me just plug this in. Okay, no, I'm still getting USB device not recognized. I can take a look at this 5-volt waveform again. Let me power it. That's 5 volts. Yeah. I mean, does that look bad? I can compare it now to the bad board. Hang on. Wait. Yeah, that's the bad board. This is the good board. It looks exactly the same. So, if I want to measure between them, are you saying I can attach my ground to D minus and the positive to D plus? I mean, it's possible. Like this, I guess. Problem is, it only does something. Oops. It only does something when I reset the board. It doesn't like that, actually. Yeah, when I put the probe across, it disconnects the USB device. My time scale's all wrong. That differential looks a bit trash. I don't know if I'm doing it right. Now just look at the each one individually again. I'd like to know if I'm on the right settings on the scope. Let me just switch over to the good board again. Sort my trigger out. So this is the good board. That's one, that's the other. That's one, that's the other. Now let's move over to the bad board. And I'll refresh. So there's ripple up there, like we said. But there's no ripple on this one. Yeah, so if I go to the controller, I have checked all this, and they are physically connected. So it's pins 3 and 4. That's pin 3. That's pin 4 with the ripple on. Amplitude is what? 3.3? And the other one, they're the same amplitude. I don't quite know where the yeah, it's a brand new controller, this. We could put another microcontroller on it. Do you think we could have a bad microcontroller? The second signal. Sorry. That's the ripply signal. But, I mean, that's logic high, isn't it? Whatever that is. And this is the other signal. Looks like a good square wave signal to me. I wonder if, as this could be a stupid idea, but maybe I just need to clear my COM ports. Let me just try device manager. I do eat up the COM ports on this machine. I'm up to COM 11 already. A little bit of housekeeping. Okay. No, wasn't that, unfortunately. Didn't see anything. Just catching up with you. Yeah, okay, so let's have a look. So I'm directly on the pin now, on the controller. And do it again. And the next pin. Yeah, of course. I don't think I have such an analyzer. A little part of me is thinking, shall we just change the microcontroller? It could also be the port. The socket. But the signals seem to make sense. What else is going on around that socket in the schematic? Only the CC. The CC pins are going to ground via resistors. And the SBU pins are actually left open. Not connected to anything. They're both quite hard to change, to be honest. And I don't have loads of the... Well, I don't have any new sockets to put in. I'm wondering if those were like somehow shorted to something and they could interfere. I don't know. Well, we got to try something. I guess we can try changing the controller. What do you think? A quick hot air blast. Lots of flux. This might get smoky again. And try and keep it going this way so I don't melt the sockets. Come here. Yes, I'm worried about the crystal. I'm trying not to blast it directly onto it. We're off. One microcontroller coming up. Maybe I don't know if maybe my scope's not set up right to scope that signal, but yeah, I don't know what to say really. It works on the other board. These tweezers are very tacky. Alright, I'll just try and tack it in on this side. Not too sold on that. Right, no, I'll do that. I'll do that side last. Touch too much on there. It's one edge down. This one will be awkward because of the connectors. We'll go around all these with a waggle test anyway. Too much again. Okay, I'm going round for a waggle. I don't imagine they're all nicely joined. There's one. Okay, so that's a brand new 80 mega, which has only been fitted once. I don't see any bridges. So shall we see if it programs for a start? See if I haven't fried the clock. It's plugged in. And board is set to Arduino Micro, programmer USB ASP, burn bootloader. Yeah, it's burning. I'm quite sure that's gonna burn. Hiya. Launch it in draw. Alright.
Yeah.
Okay. And then I'm over here giving it a go. It worked. It got it straight away. Hey, we might be in business. There he is on COM3. Amazing. Great success. So now I just need to tidy up a little, make way for a spectrum. God, I've made a right mess here. Okay. So I've made a little bit of progress. I'd like to have a look. I'm rushing a bit now, though. Sorry. I'm gonna just. All right. Let's do it. Let's do it. So my scope is on. There's one. That looks miles better, doesn't it? Oh, that's crispy. Okay. I think my battery's died again. The microcontroller had been taken off. It'd been on and off. Okay, let's just go overhead. is our machine. I'll plug that in and plug in the USB. And power the machine. And this is going to be interesting. How am I going to do this? So, that's what we're seeing. And got some code here. And we kind of had to see everything at once. But let's see. This is the code for the mini map. I think I'm going to do a save as. New board first test. And delete lots of stuff. I don't need any of this. I need this. Don't need any of this. Don't need any of this. I'm just going to be listening for interrupts, basically. This is the Attic Attack minimap, but I'm just going to do a basic test on it for now. So this is the interrupt routine, and basically it's listening for memory writes. I think I've explained it. So I'm just going to leave one in. If address is 60049, I'm going to say serial.println .print at, you really can't read this, but I don't know how to zoom in. Could do this. So at address data is data. Hopefully that will download to the board. Typo. Yeah, it's compiled and it's going. And we can look at the serial monitor. So where shall I put the serial monitor? I'll put it up here. And I'm going to type in a program which says 10 poke 60049. That's the address that we're looking for. And we're going to poke 42. Then we pause. 100 and go to 10. And I'm hoping we're going to see. There it is. Maybe I could say 5, let I equal 1, edit, we poke I to there, let I equal I plus 1. Now 16 if I equals 254, then let I equal 1. Wait, that's going to take forever. 20, pause, let's go 10 times faster. And you see it's capturing it. Oh, very good. You know your stuff. Well, this is working. I can't see very well. Is it missing any? Shouldn't miss any at this rate. This is fast enough, slow enough for it. Good, eh? So if you know your game is storing the, say, the player health at 60049 memory location, then you've got these ports to play with now, I/O ports, and you can do anything you want with it. Is it going to loop round? Yay! Lovely. So what I was hoping to set up today, and I've run out of time, is this Manic Miner scoreboard. I already have the sketch, but the sketch is written for the old version of the peripheral interface, this one. Which uses different ports, so it's not compatible. So I need to do a bit of coding to rewrite the Manic Miner sketch to work with this. So it tracks the score, but it also tracks the air gauge, the remaining time on the air gauge with an LED strip, which I've got somewhere around here. This one. From Pi Hut. It's quite a nice little compact strip, actually. Yeah, exactly, Derek. So I want V3 to replace basically all of this with just some level shifters and a 2350B. So I've got this little breakout board for it, and this should have enough PIO pins on it to take the address and the data bus and the control signals and handle all of the listening in PIO, which will be easily fast enough to just track the entire contents of memory, and it should be able to pick up writes and reads, so it would rapidly create a mirror of the entire contents of the Spectrum memory, and then you can do whatever the hell you want with it, and you'd still have 2 cores free on the chip to play with. So it's going to be a lot more powerful than this, but I'm pleased with that. It's working. We've fixed it. And that was a tricky day of soldering, I have to say. So I think I'm going to have to stay up a bit tonight and just make sure I've got this working with the Manic Miner LED strip and the scoreboard here. I should probably put back on the voltage regulator as well, but it's just extra risk now in case the power circuit makes something go wrong. Oh boy, I'm knackered and I'm out of focus. Yeah, that's exactly what they do. But I think those are looking very specifically for the ULA signature in the data in the memory reads, and it reconstructs the screen I don't think it's reconstructing the entire memory, and you could do a lot. I think you could do a lot with it, couldn't you? If you had the entire Spectrum memory in real time running on a Pico, and you have access to the GPIO pins. Yeah, exactly. So you could use it as a HDMI interface, no problem, but you could use it for debugging. You could do all kinds of stuff. Yeah, I'm gonna finish in a minute.
Alright.
Alright, yeah, 1 second.
Hasn't made it.
Alright. That's fine.
Well, sugar rush.
Right.
Oh.
So I'm out of focus again. Okay, I'm out. I've overrun, and I'm gonna have to do some more programming later on, unfortunately. Why is my code stopped running? Hang on. It's like it's lost the... I said I was done. I'm worried. Wait, why has it stopped running? Okay, it's working. Maybe just a USB blip. Yeah, this struggles. If you have like sequential memory writes, it won't get it. And reads, forget about it, because the data bus is only set up in the Z80 read cycle for 1 or 2 cycles, and you just cannot react fast enough with 18 mega. PIO, on the other hand, I think you could do it, although the code's going to have to be quite clever. Oh boy. Okay, I'm done, chaps. Thanks for hanging out, and thanks for all the help with debugging. I learned a lot. I hope you all enjoy the rest of your night. And if you, yeah, I'll see some of you down there tomorrow, I guess, or Sunday at RetroFest. Come and say hi. And hopefully I'll have this working by then. I'm going to leave you on my outro screen. You can see a ZX Spectrumized gym. And wish you all a good evening. Catch you in the next one. Cheers. Bye, guys.